Hi guys, Screencastify is giving me a little bit of issues this morning for whatever reason. I don't know why. So I can't really see what you guys are. I can kind of see myself, and that's it. But I double checked. I did a couple of test ones, and you should be seeing my desktop screen and the Blackboard opening up. Hopefully that's the case, and I'll check later. What we're going to do today in day 11 is the last little bit of see there, it just shows this. Hopefully you're seeing the actual screen. I'm going to assume so because I did a couple of test runs on it. And we're just going to keep going because we need to make video. Okay, so today is day 11, and this is our max min unit, unit 5 in calculus. And that's number 5. Okay, and this will be our last topic that we have, and that's speed. Today is the last topic: speed, position, speed, and acceleration. Okay, problems. So this isn't really. It's really kind of like related rates, but not the same thing that we were doing in the distance ones, the sphere ones, and the cone ones that we did. This one deals with position, speed, time, and acceleration. Basically, we're going to be looking at physics-related application to the derivative. And then we'll look at some examples of that. And then practice. And that'll be our general idea for this morning. Like I said, I hope everything's working out there. I can't really see what you guys see. Screencastify is giving me a little bit of issues this morning. I spent some time on it, restarted the computer, reinstalled it, did a whole bunch of things. Hopefully they'll fix that problem soon. But after doing a couple of test videos with it, it seemed to be recording the side, even though I can't preview it when I looked at the video. So I'm hoping that sticks with it and that you guys are actually seeing what you need to see. If not, it's futile efforts by me here this morning. Okay, so I have to open up on my other side my little background here, as I haven't done that yet due to the fact I was playing with Screencastify most of the morning this morning. Wasted it away. So let me do that while you get, should have done it a little bit earlier here. Okay, so, computer's a bit slow. Give me another minute here. It's getting there. And one more click, or no, 2 more clicks. We're into physics. And sample, there's my samples. And we want to do distance. Yes, why did I click into physics? Who knows? It's calculus. Sorry, guys. It's been a weird morning this morning without Screencastify working. Calculus, that's what I want. Give me a second. I'm not going to shut this down because last time I did, I had trouble starting it up again. So there we go. Okay, so we're into max min problems, and we're going to be looking at the speed, acceleration, and distance problems in detail. So the first thing we should know is that this is an application of derivatives. Okay, so how do position, speed, or velocity if you like, another word for speed, and acceleration of a particle relate? And the first thing is, for any object, that moves in a straight line, okay, with a constant acceleration, obviously, that, or as in physics we call it uniform acceleration. We can say the position sorry, I can't type now. Equation is noted as S bracket T, where S is a function of time. Okay. Here is Vt denotes speed or velocity. Particle. And At, the acceleration of the particle. Okay. So the relationship that we have in calculus as derivative is a slope. Because derivative is a slope of a graph at a particular point, that slope, if you remember that velocity is the slope of a distance time graph, from physics, we can say that calculus, if you have S, if you want to find Vt, velocity, is the derivative of the position graph at any time that you might have, and acceleration is the derivative of the velocity graph. Because acceleration is the slope of a velocity time graph. Of the position, I guess not graph, we should say of the position equation at any time. And acceleration is the derivative of the velocity equation anytime. Okay, that comes from the graphic. So if we write that out calculus-wise, it looks like this. Sure is weird not having any preview. Okay. Hopefully it's going good. I think Google usually gets their stuff fixed pretty good, so I'll just wait a bit. Okay, so that would mean if we say V equals velocity, A equals acceleration, and S is position. We can say that v at some time t equals s t with the prime there, which means derivative. Okay, and acceleration at some time equals vt prime. Okay, and that's the relationship between acceleration and speed, velocity, whatever. You can also take the second derivative if you want. So you could say that acceleration also can equal s prime prime t, which means take the derivative twice. So these are the relationships that we're going to use to work out speed, velocity, acceleration type problems. It's not very difficult, really, to work with. Okay, so let's start by doing a very simple example or two. Okay, I guess the other thing we should talk about here is that all of these are instantaneous. So this is instantaneous at that point in time. Okay, so that's the instantaneous slope at whatever time t you pick. Okay, so if you want to get average velocity or average speed, you have to take the difference between the two, just like you do in physics. Okay, so let's do an example here. And I'm just going to do it, copy the example I have here, and let's do this on the next page. Okay, let's go with blue or something. Oh, this one's ugly. Backspace that in there. Should fix that up. There we go. Okay, so a particle moves along the x-axis so that the distance is given by the function st is equal to 3t squared plus 12t. Find the average velocity from 1 to 5 seconds, the instantaneous velocity at any time, the instantaneous velocity at 4 seconds, where the particle is when the velocity is 72 meters a second, and the acceleration at any time. So those are some physics questions. So the first question is the average velocity. So we have to find out the velocity at 1 second and the velocity at 5 seconds and subtract the two to find or do an average calculation, which is initial velocity times final velocity, final velocity minus initial velocity over final time minus initial time, which will give you that equation. It's a physics equation when we do it. The second one, the instantaneous velocity is just the derivative at any time. And the instantaneous velocity at 4 seconds, we'd have to plug it in, where the particle is when the velocity is 72 meters and the acceleration at any time. So let's begin by solving these. Okay, let's put that up there. So the first thing is, let's get this into our marker. Okay, so the average velocity. So we have to figure out in the velocity at 5 seconds. Okay. And the velocity at 4 seconds. Okay, so that's the first thing we have to do. Okay, so we got to figure out the velocity equation. So if velocity is a derivative of position, okay, so we have to take the derivative of this. So that's going to be 6t plus 12. Okay, that's what that equals. So then therefore, if we go velocity at 5 seconds, it's going to be 6 times 5 plus 12. Okay, and this is in meters per second. So this is going to be what do we have here? 3042 meters a second. So that's its instantaneous velocity at 5 seconds. And its velocity at 1 second, 6 times 1 plus 12 equals 18 meters a second. Okay, so there's our two velocities. Okay, now average velocity, V average equals final velocity minus initial velocity, final time minus initial time. Okay, so that would be 42 meters a second minus 18 meters a second, all over, what do we got, 5. Well, this is going to give us, pardon me guys, this is going to give us acceleration. You don't want acceleration. This would be an acceleration, not, I'm going to exact. Okay, so we have two speeds. You have to get the average, just a regular average question. Plus. Sorry. Plus. Okay, and then we have two velocities, so we divide by 2, get our V average. I was doing acceleration there. Okay, so 18 plus 42, that's 60 meters a second divided by 2 equals 30 meters a second. Okay, so that's an average velocity. Taking it, first one and the second one, averaging them out. Okay, the next question is the instantaneous velocity. So that's a little easier. The instantaneous velocity at any time is just the derivative, which we did take already. Okay, so at any time, this is the instantaneous velocity right here. Okay, and then it says the instantaneous velocity at 4 seconds. So 4 seconds, we plug it in. So 6 times 4 plus 12. Okay, that's 36 meters a second. Okay, move this up a little bit. Oops, that's too far up. Okay, D is where the particle is when the velocity is 72. So you got to take the velocity equation, equal it to 72, and then keep the time. So we're going back to equation to B, this velocity equation, we're plugging in 72, and now we're solving for time. So we subtract so T equals 10 seconds. So that means it's at 10 seconds. Okay, Okay, and then where the particle would be at 10 seconds, it would be S at 10. That would be its position at 10 seconds. So that would be 3t squared plus 12t. So in this case, it'd be 300, 3 times 100 plus 120. So this would be 300 plus 120. Hopefully I'm not blocking you out there. I'll move that up. It goes 420 meters. So it would be at 10 seconds, it would be at 420 meters. Okay, and the acceleration at any time. Acceleration at any time is the derivative of velocity. So we take velocity, which was this equation right here, and take the derivative of it. The derivative of that is 6. Okay, and the expression for acceleration is meters per second squared. Okay, so that's kind of how it works for an equation type problem between speed, velocity, distance, and time. Remember, speed and velocity, same thing, except one's a vector. Okay, let's maybe do another example here. But this is about as hard as they get. They're not that difficult. It's a good thing to finish off on in the unit. Okay, let's do a little more challenging one. Let's do one where we have to do a little bit of a sign analysis. Okay, let's do yeah, go ahead. Okay, so let's get this one here. Screencastify wasn't working this morning, so it gave me a little problem. All right, there we go. Let's get that fixed up. Okay, so the position of an object on a line is given by the function s. Let's get that all into one line here. Cubed. There we go. Cube up there as well. At 2t cubed minus 15t squared, okay, plus 24t. Find the velocity at any time, the velocity at 6 seconds, where the object is moving left and right. So you have to do a sign analysis of the velocity function. And the total distance the object has moved up in the first 6 seconds, and acceleration at any time. So a typical type question. Okay, let's get that fixed. Sorry about the being a little bit choppy this morning, but like I said, I can't see any of the previews or anything, so I'm hoping that it's working out okay. Okay, so let's do the first one. The velocity at any time is just take the derivative. Okay, so let's do that first. Okay, the velocity at any time equals s prime. Okay, so the derivative of s prime is what we have to do. So that would be 6t squared minus 30t plus 24. Okay, sometimes you'll have to factor that to find out when the velocity is 0 and things like that. So that's what we're going to do when we do this here, moving left and right thing. So the velocity at 6 seconds, you just plug it in there to what we just derived. Okay, and that's going to give us 6 times 36, that's 216, minus 180, plus 24, and that's going to give us 60 meters a second. Okay. And it says where the object is moving left and right. So we have to do a sign analysis on the velocity function. So sign analysis on the velocity function. So we're going to take this velocity equation and we're going to factor it. So factor first. Okay, so that's going to be, and set it to 0. Okay, so that would be 0 equals 6 times t squared minus 5t plus 4. Okay, and then we can factor this into t minus 4 and t minus 1. Okay, so that means at velocity is going to equal 0 when t equals 1 and 4. Okay, so that means we're going to just do a little sign analysis here to see whether it's going left or right. Okay, so if we do our little line here, there's 1 and there's 4. Okay, and then we go for t minus 1, t minus 4. Okay, we put the 0 in there. Put the 0 there. Okay, that means that at that time, now the product of those two is going to tell you whether it's going left or right based on the sign analysis. If it's going backward, or if its velocity is negative or its velocity is positive. So in this case, its velocity is positive. Okay, in this case, its velocity is negative. In this case, its velocity is positive. So therefore, we can say that we can, just like when we do intervals, we're talking about the velocity or slope in this case. Okay, so it's going to the right. Okay, from okay, so from infinity, right, to 1. Okay, so that one there is blank because right there, that's a 0 velocity. That's where it flattens out. This is where it changes. Okay, and also it's going from 4 to infinity here. Okay, that's going right, positive velocity. Left, backwards, it's from 1 to 4. Okay, and in here, at 1 and 4, it's going 0 because that's where the velocity is 0. It stops and changes direction. Okay, where the total distance the object has moved after 6 seconds. Okay, so that's pretty easy. We just have to plug it into the original equation because we have the original equation given to us. So in that case, we take our original equation. Just let me get it here. Okay. And you're like, okay, well, total distance. Okay. Now, the one thing I want to mention here, right here, is there any negative time? So this could be a 0 as there is no negative time. Okay, even though we put a negative infinity there, which is what I was supposed to put, not infinity. But we could say, in this case, it's going to start at 0. We started at 0 times, so, right? That would be our total. So we could find the distance it went here, the distance it went here, and the distance it went here. So find the distances. Okay, so looking over here, we can find the speed at 0 is going to equal 0, or the distance is going to equal 0. The distance at 1 second, okay, so that's going to be going, the equation is, what was it? Equation 15t cubed, right? 2t cubed minus 15t squared plus, okay, so 1 cubed minus 1 squared plus 24t. So this gives us the distance that it's traveled here. Add those all together. 2 minus 15 plus 24. This is plus 2 minus 15, that's 13 plus 24. That'd be 11 meters. Okay, the next one from 0 to 4. So we got to do it 4. 2 times 4 cubed minus 15 times 4 plus squared plus 2 times 4, or 24 times 4, pardon me. Okay, so if we do that one, this is going to be, what do we get here? Let's get the calculator for this one. 4 cubed is, okay. Oh boy, wrong button there. There we go, that's better. So at 128 minus 240 plus, so this is negative 16. Okay, so this is the position. This is not the distance. So this is why we have to do it this way, because we're finding out where it drove to, what position it stopped at. So we're going to actually figure out the total distance here. And then at 6 seconds, okay, and that one's going to be 36 meters. So this represents positions. Okay, so now when you think about it, what happened? So from 0 to 1, you went forward 11. Okay, from 1 to 4, you went backward. Okay, now this is tricky. You have to look at the difference between these two. You went from 11 to negative 16. 11 to negative 16 is 27 meters. Okay, and then from 4 to 6, because we didn't go to infinity in time, we went only to 6 seconds, you went up to 36. So you went from negative 16 to 36. So what would that be in total distance? That would be 36 plus 16 more. So that'd be 50, what would that be? 52. You went forward 52. Okay, so the total distance that you drove is you went forward 11, backward 27, forward 52. So 11 meters plus 27 meters backwards plus 52 meters forward. So this is the total distance you drove looks like 90 meters. Okay. So this gives us our position that we're at. This gives us how much distance we drove to get to each position. Okay, so that's a little bit of a tricky one there. Okay, and the last question, E, the instantaneous acceleration at any time. So you got to take the velocity equation, prime, and that equals the acceleration at any time. So the acceleration can be the derivative of the velocity equation, which in our case, if we look at the velocity equation as being this one right here, and we take the derivative, that would be 12t minus 30. Okay, and that's basically the whole point, relationship between, distance and time. Okay, the only tricky one here that we did would maybe be this one here when you're finding distance. Remember that in physics, when you're talking about distance, it's just how far you traveled without regard to whether you're going backwards or forwards. So in this case, total distance doesn't always it's not just the plug-in. Like that plug-in is the position of the times. So where you're sitting at that particular time. And to get there, there's a certain amount of driving or moving that you have to do. So keep that in mind. Okay, so the other thing that I want you to do then, let's just take the preview out here. That's about 37 minutes, is some practice. And I'll put the practice up next day. There's 7 distance speed practice type questions. So hopefully this one worked out. And even though I can only see myself, if you look at the preview, it looks like this. Hopefully that it's actually showing the screen, and I'll check that out.